Dear students, let us continue with the problem. In the previous video, I have stopped at to calculate the earthwork in banking. We have learned how to work out the quantity of earthwork in banking. Now, we have to know what turfing is. Turfing is the preparation of landscape like this at both the sides of embankment. This turfing can be done only for the banking and not for the cutting. That is the growing of grass on the side slope areas. These are the turfing. This is what turfing means. On both the sides, this turfing can be done and it will be done only for the banking. That is filling. Since in the given problem, starting point till the 300 meter, everything is banking and in between there is no cutting. So for that purpose, we have to prepare this table. This is the calculation of area of side slope for turfing. We need to give the area of turfing. This is area. Remember, this is area. This area we have to give. This is not volume. To find this area, we need two dimensions. One is this dimension and the other dimension is along this side. That is from 0 to 300 meter. This is one dimension and this slope is another dimension, and this length, this side length will be same on both the faces. 2 times we have to take. First, let us see what is the length of this. Yeah. This, we know that this is in the form of a right angled triangle. So we know this is D and this side it is SD. So this face will be square root of SD square plus D square. In both, D is common. If we take D outside, the remaining will be square root of S square plus 1. So this is the length of this face, and this length depends on D value. Since we are doing dm, so this formula will become dm into square root of S square plus 1. See, sloping breadth is dm into square root of S square plus 1 multiplied by length. Since this length is 2 times, the area of both the sides formula becomes 2L into dm into square root of S square plus 1. So this serial number and distance and this dm, we can copy it from the previous table here. Mean depth. We are not taking depth. We are directly taking this mean depth which we have already calculated. Here, this is dm. For this, it should be dm into square root of S square plus 1. Value of S is given in the question. It is 2. S is equal to 2. So the formula becomes square root of 2 square plus 1. Only dm is a variable. Square root of S square plus 1 remains constant throughout. So for the corresponding dm, you can work out. Calculate this. And we are working for only 30 meter intervals. That is the constant distance. That is from this point till this point at a distance of 30 meter. what is the turfing area. Similarly, at every 30-30 interval, we are going to find out the turfing area. So finally, this will be the total area of turfing. If we do this till the end, here also you can see the first row is blank. So the total turfing area will become 911.02. This is the total of this whole areas. So this is how to calculate the side slopes for the turfing. So till here it is a detailed estimation. Now you have to put it in an abstract table. Abstract table remains constant throughout, whether it may be a building or steel, anything. This abstract table remains constant, it doesn't change. So item number, particulars, quantity, unit, rate, amount, everything. We have earthwork in banking. For this quantity, unit will be cubic meter. This rate is given in the question. So we'll get this amount. Similarly, the turfing area, same thing, holds good. So totally we'll get this. Here also same thing, 3% contingencies, 2% for work charge establishment, and the grand total will be this. So this completes the problem. Just to summarize, in the given question, they had the data at every 30-meter intervals, the ground level, and they wanted to do a proper road level with the specified gradient which is given. For this case, they wanted the cost of construction of the earthwork, that means for the preparation of the road, and the turfing area, both they wanted. We have calculated using mean depth method. So mid-sectional area method we have followed. So we have calculated formation, and we had a graph also. And remember, these graphs are not required unless they ask. Only if they ask, you can plot it like this. The graph should be in the x-axis, it should be distance, the y-axis it should be RL. So this will be the RL of the ground, and this is the formation level. You can clearly make out and draw the proper graph. So it will be done. If you have any doubt, we can discuss in the next class. Thank you.